So thank you everybody for joining us today. Really excited to talk about this particular topic in Wi-Fi, focus on this because we all know that Wi-Fi can bring about some pretty strange things, right? And so really excited to delve into the guests that we have today. We are very fortunate to have George Stefanik and Jason Bashara. So George, why don't you go ahead and introduce yourself? I think most of our audience knows both of you, but just on the off chance that someone doesn't.
Sure. I'm George Stefanik. I'm a wireless consultant with Active Expert. I've been in wireless 15, 20 years now. Have a strong passion for Wi-Fi. It's something that is really a strong focus for me and my company. Very appreciative to have the opportunity to be here today as well. And looking to share some of the challenges that, very unique challenges in mining and automation today with you guys. So thanks for having me.
Absolutely. And Active Expert was actually nominated for a Wi-Fi award, right? So that was pretty amazing.
George, that's cool.
Active Expert is really a leader in the wireless world and what they do. And so we're really excited to have you, George. Jason, excited to have you. You have had some pretty strange environments, and I'm excited to talk about some of the challenges that you've had. So Jason, why don't you go ahead and introduce yourself?
Sure. My name is Jason Bashara. I am a mobility architect for Presidio. I've been involved in wireless and Wi-Fi probably back since the 900 megahertz days. So 15, 20 years. I've always had a passion for RF from a young age with remote control vehicles and helicopters and things of that nature. So it just seemed a natural fit for me to mold into the Wi-Fi.
Is that where the bad driving came from? The RC cars that you would like crash them? Like
absolutely.
Helicopters? Like,
absolutely.
Just checking. Just checking. All right. So today, strange environments, right? So all networks, as we know, are not created equal. They're, with the advancement of technology and how things change, there's a lot that comes with that. And so today we're going to specifically look at some of those industrial environments. We're going to look at some examples, some chemical power plants, automotive manufacturing, some pipelines, even all the way to the North Pole. So really excited about that. But these are not your typical networks. They don't have the typical requirements that you need. The demand is very different. The environment, temperature, everything is dramatically different. So why don't we start with you, George? So why don't you share some of the different types of environments that you've been in and some of the unique challenges for those specific environments?
Yeah, sure. I'll be happy to get started and kick that off. Having experience both in healthcare, enterprise, higher education, we're fortunate at times to get these really unique projects where you're looking for something in a mine, for example. And those particular projects are rather not only interesting, but the length of challenges, the list of challenges that you have to overcome. So for example, two recent projects that I worked on that I'd like to share with everyone is one was an open pit mine for a coal company. And their specific need and challenge that they were trying to overcome was to pull data off of some mining trucks. And when I say mining trucks, these are some of the largest trucks in the world. In fact, they're so huge that you have to take a ladder to get up to the driver's seat. And those trucks are, a couple $100 million. And, they need to pull data off those trucks to make sure that if there's any problems that they know in advance as parts start to fail. So there's sensors on the trucks, for example, that will relay over the wireless network to a database, and technicians can look at an iPad, for example, and look what's going on that specific truck. So as parts start to, or sensors start to alert on the items, they could pull that truck off aside and then start to maintenance that truck rather than wait for a failure to happen. Now that sounds easy enough to do, but it's really not, because you're actually in an open pit mine. You don't have power where you can just plug in. You have challenges with constant excavation. So, it's an open, living, breathing mine, right? So where you have a high wall today, it's flat tomorrow, for example. So a lot of challenges that go into that. Another item is for automation. Automation comes in a lot of different flavors. In mining, automation is actually very important. you can actually remote control different devices, trucks and dozers and things of that nature. And what we call the last mile is Wi-Fi. So, you know, a lot of these trucks are operating over unlicensed frequencies, and making sure that we're able to relay that information and remote control those dozers, for example, in trucks that happen in pods, sometimes miles away. In fact, many times you can actually remote control a device on the other side of the globe as long as you have enough connectivity. So, you know, those are, you know, some unique things that I've been involved in the last year. And, you know, people would ask, well, why would you want to, you know, remote control a dozer, for example? Well, if you look at the statistics, believe it or not, a lot of the operators, when they get hurt, it's usually getting on and off the dozer. Not only that, but if you're waiting for product to dump and you're idle for, sometimes if collectively over a 10-hour shift, you might be idle for 3 hours potentially sometimes. Whereas if you're doing automation, you could be sitting in a pod and remote control multiple dozers, of course, individually, but you don't have to drive to certain parts of the mine, for example. You can actually sit in one pod and remote control those dozers individually and be much more time efficient. Some recent ROIs and studies that were done for the last customer I was working with, the return on the investment was a short 3 years, 36 months
Wow,
to
that is a pretty short
collect
time
all their
frame.
money. Yeah, yeah. So I thought that was pretty cool.
Very
But
cool.
I'll
And
let
so just one quick clarifying question. When you talk about dozers, some of the folks are asking, what is a dozer? You're talking about the bulldozers and
the bulldozers, absolutely right. So,
right?
so imagine, you know, a D8 or D9 dozer. It's a very, very large industrial mining dozer, and there's no operator in it.
Wow.
And you can actually remote control that dozer from a pod.
That's
And that pod typically looks like a shipping container. And it all happens over the wireless network.
That is
Childhood dreams have come true.
Yeah. You get to play with the big, like you go from the little baby dozer when you're little and then to the really big remote control ones, like as a grown up, right? That's
right. Absolutely. But a lot of challenges when you're looking at that type of environment. You know, again, how do you get power there? How do you extend the wireless network? You get involved in, you know, working with solar panels and trailers, solar trailer trucks, etc. Some things that we're going to talk about here in the next couple of slides. So I did a lot of talking. I'm going to let Jason take this.
No, that's fantastic. So Jason, you also have had some unique, you've been to the North Pole, you have done pipelines, you've done refineries, chemical plants, power plants. So why don't you share some challenges that you've had in those environments?
Sure, and to add to what George has already said, you know, these environments generally are remote, they're ever changing. And one of the things that I will say, especially when it comes to refining and chemical power plants, is sometimes Wi-Fi client connectivity isn't the main driver. The main driver a lot of times is backhaul for sensor data, that being temperature, pressure, tank gauging, things of that nature, with the Wi-Fi being a byproduct for client connectivity. In the case of oil pipelines, you know, you're in very remote areas, often staying in work camps with other folks that work on the pipelines themselves. There becomes a lot of concerns from environmental issues, not only from a conservation point, but to a safety point as well. You know, in certain parts of Canada, you know, brown and grizzly bears are commonplace. In the North Pole where I was, there were polar bear concerns, which we'll touch on here in a little bit. So, you know, along with the refineries, we've touched on automotive manufacturing. You know, in automotive, there can be multiple requirements in a different plant because of the different types of nature of the work performed. You know, you have stamping areas where they will stamp out the parts, which have different automated machines that may or may not require Wi-Fi connectivity. You have UV dryers that can play havoc with 2.4 gigahertz due to the nature of the way that it goes about exciting gaseous mercury to about 2.4 gigahertz. So if you've ever run into those, you know that you'll have serious problems. The other thing, limestone quarries. So I've worked in a limestone quarry that was actually turned into cold storage facility. Some of the major problems with that are cable paths. A lot of core drilling involved in order to get your data out to where it needs to be. And the question becomes of, you better make sure you know where you're going as well, because it's very easy to get lost in one of these places.
Okay. So we're going to talk more in detail about that in a few minutes. To the folks asking, yes, we are going to be sharing the recording. It will be uploaded onto our YouTube page. I know this is really kind of cool. So Jason, you mentioned polar bears. It's crazy to me to think Wi-Fi and one of the challenges is polar bears. I'm just saying, so I can't wait to hear more elaboration on that. But I know folks—
Yeah, from a Canadian perspective, I'd like to know a little bit more too.
Yeah,
Sure.
yeah, absolutely. The brown bears and the black bears and the polar bears up there in Canada. Stu's got some challenges as well, right?
With deer, yes.
And everything else.
Those are polar bear snacks.
Yeah. That's fantastic. So I know everyone's really excited. So let's specifically talk about some of these use cases. So George, we're going to start with you and talk about mining. You talked about the bulldozer. So I'm guessing these are some of those dozers and some of the equipment that you were able to remote control and some of that.
Well, no, actually what you're seeing there, these are some photos that we had taken for the mining project that we were working on. Those trucks that you see there is what we call a ready line. And before the start of each shift or the end of each shift, that's where the trucks get parked. What you're not seeing is that there's another whole row of trucks there. And when you do up the math, it's like $2 billion. That's with a B, $2 billion worth of trucks. Those trucks are the 789s, which is the second largest mining vehicle in the world. And it's a very, very big truck. These trucks, obviously, with the cost of them, they use approximately about $15,000 a day in diesel. So do that math, $15,000 a day per truck in diesel costs, and that's running around the clock. So they can't afford these trucks to be down. In fact, preventative maintenance is critical to their business. Having a truck that is that expensive to be down for any purpose impacts mining significantly. But yeah, so in this particular case, and I think Jason put it best, is, Wi-Fi is a byproduct of what we're trying to make happen here. And that is the sensory data coming off of these trucks. Effectively what happens is that the truck gets a whole new computer system installed. And these computer systems are tied to a wireless radio, and that in itself is challenging. And putting these radios in a spot that they're not going to get damaged. Over the years, working with other folks in mining, a lot of lessons learned on where you can put antennas, where you can't, getting the right radios because of the vibration. Over time, these things will vibrate off, for example. So there's been tons of years of experience over the years with a lot of other folks that you do some lessons learned and figure out, you have really 2 or 3 options where you're going to put these radios that over the long term, that they're going to last. But these trucks here are all transferring sensory data. And the image on the right there, I thought it was a great image. It's a cloud cover over top of the mine there. What you don't see is there's probably a good 300-400 feet of mine below that cloud. But we're doing backhauls, for example. This was a temporary network that we set up for this particular customer until their product came in. But it's a lot of work that gets involved to make these networks to run. For example, like I said, power and things like that. But specific to this mining operation, it was all sensory data. It was all data that we needed to pull off tire pressure, different types of sensors on the engine, sensors on the lift. It can tell you how much ore is actually stored in the bed of the truck. All this gets driven into analytics so they could see during a shift, how many, what employee effectively was more productive than another employee potentially, how far the truck drove, how much diesel did it use. And you're able to actually take that information and it goes back and compare it with other trucks. You can start to see, well, why is this truck not operating as fast, or why is this truck always, underperforming? So it allows them to really start to investigate that data.
Very cool. Very cool. So some automation. Let's talk about
automation. Yeah. So, we talked about the mining side. This is actually part of the mining as well as automation. What you're looking at there is, as a wireless engineer, we look at, zeros and ones. But now when you're trying to achieve that byproduct of Wi-Fi for sensory data, for example, and for automation, we need to get wireless out to these remote areas. And one of the ways that's commonly done is with a solar panel trailer. And that's what you see there. These trailers get built out. A solar study is done depending where they're going to be used at. So this way the proper batteries as well as the proper panel types and sizes are ordered. So now just imagine, as a wireless engineer, we're worried about zeros and ones, but now I got to worry about and make sure that everything is built above capacity for us, right? So a solar study is done, we need to make sure that we have some extra battery life in case we get a week or two of really overcast days or bad weather. And this allows us to push out that network and make it mobile. What you're looking off to the left here is actually, it's a Cisco system. We're using Cisco mesh as a backhaul on 5 gigahertz. That's where you can see the panel antenna off to the right on the very far left picture. And the 2 antennas that are up top that are angled down are sector antennas. These antennas we found to be the best for client connectivity. And that allows us to actually look over top of the operation. Wherever we can, we like to look over top of the operation. So this way we have a better chance of getting associated to those radios on the trucks. And understanding that, we have to have line of sight back to our tower. So we have to make sure wherever we position these, we're up over top of the operation and line of sight. And then also too, we want to make sure we're not in an area where we're not going to have any sunshine. Or where we have sunshine. So we don't want to be up next to a high wall where we might have some issues for the solar panels. Also with the solar panels, you have to make sure that they're wiped off at least once or twice a week, because they do get dusty. They have to be moved out when blasting is done, for example. But that's an example of a solar panel there. So on the automation side, the automation itself, we're talking about dozers, for example, that are very, very large, very expensive. The dozers run about $3 to $4 million a piece. And part of that automation project that we were working on and still working on, it's actually expanding, is to provide connectivity to dozers in a predefined area that allows them to remotely operate those dozers with no operator in them. So it's kind of eerie when you see this dozer drive by you and there's no man in the cab. But that allows that the company, when they did their ROI, that they looked at between about 36 months was going to be the return on investment because of the amount of operators that they have, the remote location that they're in. They're about 2 hours out from anywhere. So, they don't have a huge selection of operators that want to travel to work 2 hours in some cases. They often have like a remote camp, was kind of what Jason mentioned. Also, when they did their study, they found that most issues happen from operators actually getting on and off the dozer. And the other thing that they had was, I mentioned earlier, is that their ability to flux. So they can control one dozer waiting for product. And if they're idle for a period of time, while they're sitting in their station, they can actually flip to another dozer at a different part of the mine and start operating that one. So you can see now that, they're being much more productive with their time.
Yeah. Real quickly, George, someone asked a question on the previous one in mining and you had that cloud cover. Did you have devices underneath that cloud cover that had to be powered? And how did you, if so, how did you get power to those that are under that cloud cover?
The cloud cover, that really didn't affect the Wi-Fi much at all. But there's solar panels under there and they run on batteries. In fact, the solar study in this particular one, you see 2 panels there. We only really needed 1, but we spec'd it out for 2. And there's actually 2 large battery cells in there. We only needed 1, but we spec'd it in for 2. So the runtime on that particular trailer setup that you're looking there and the part of the country that it's in, we can actually control a 1572 Cisco AP. We can power that upwards of about 8-9 days off that battery. So, as long as you don't have cloud cover for or really bad weather for straight 8-9 days, you're going to be pretty good with just running it off the battery.
Interesting. And on the dozers that you're remote control powering, are there fuel sensors on there so you can monitor the fuel, how much it's using, intake, whether it's low? I mean, how is?
Right. So those manufacturers, it's literally a huge catalog, what you want to get out of these vehicles, right? Once you plug into the computer, whatever sensory data is there can be pulled off. It's just a matter of buying the right package. And again, we don't do the installation on the dozers.
Sure.
We're just one very small cog in a big wheel,
Right.
but a very important cog, of course. But the challenge, especially in doing the automation ones, is that there's four, and I wish I could share some photos of this, but I'm under NDA. But there's 4 cameras on these dozers, for example.
Yeah.
And, not only are we remote controlling it, but there's actually 4 high definition cameras, 2 in the front and 2 in the rear that, is streaming over wireless. And we're seeing anywhere between 3 and 4 megabit throughput for each dozer.
Mm-hmm.
And, channel capacity is a huge one for this. You run 3 of these dozers on a single channel, each one's using about 20% channel utilization. So now it becomes a very, very specific design challenge. How many dozers can you get on an AP? Where are these dozers going to be operating? How do they transition from the parking spot where you might have a dozen of these things? So we had to be very specific and challenge ourselves. A lot of it was just channel capacity. We actually would configure certain APs to certain dozers channel-wise. We found that to be the best way to get them out of the parking lot, for example, if you have like 12 of them lined up.
Yeah.
But still a lot of learning experience going on. But the automation piece,
Mm-hmm.
if you get a chance to see it, and I wish I could share some photos, but unfortunately I can't. If you go online and just Google some of this, you'll see what I'm talking about.
Yeah. And just one wrap up question real quick on that, George, to clarify, this is not in the Arctic. What part of the world was this in?
This is North America. Yeah, it's in the Northeast.
Northeast. Okay.
United States.
I think someone had a question in regards to dark in the Arctic during the winter time and solar and that. So just wanted to clarify, this was not the Arctic, this particular case study, use case.
That's correct. Yes.
Okay. George, that's pretty impressive. I mean, it really is amazing some of the things that they're doing. So Jason, why don't you share with us some of this is a particular chemical plant. So why don't you share with us your experience in this particular environment?
Sure. So in these chemical plants, refineries, et cetera, the main driver again here is instrumentation, whether it be pressure sensing, temperature, tank gauging, you name it. Any type of process value that can be gathered is usually sent back over the mesh backhaul. So as you can see, that AP is actually quite high in the air. That in its own presents some challenges. So in these type of environments, we would always do a site survey. And for the specific reason of, while in enterprise Wi-Fi, you can tell your cablers to leave a 100-foot service loop to where you can move things around.
Right.
Once these are spec'd out, there's a lot of planning that has to go in, from the different units that you may be in a refinery, to the conduit that has to be ran, to the class 1 div 1 or class 1 div 2 type of enclosures that will be needed. So there's a heavy upfront expense that is required, and to make sure for you to get this correct the first time, everything should be actually surveyed. You can imagine, somebody spending, a couple $100,000 in order to get connectivity and power to a certain location, and you come back and say, you know what, that's just not going to work. We're going to have to move it over here. That's not acceptable in these environments. So you really have to plan.
Okay.
Some of the other use cases that we have other than the wireless backhaul, I will say this, the process values as far as refineries are concerned are the most important data set that they get back into their data centers. But they do use it in other cases. So in case in being where they have mobile operators now who can walk around the plant with a tablet and look at some of these values from anywhere basically inside of a plant. This helps them actually, from a mobility standpoint, they can move around and put eyes on a certain section of the plant or a certain valve or something that may be malfunctioning, and they can communicate directly back with their control centers. Another good use case that we said, kind of like what George is doing there, in a large Saudi refinery that I actually worked in, what we outfitted it was a Humvee basically that was a first responder vehicle. And we put a workgroup bridge in it, and it communicated back through the mesh deployment. And what the intent and purpose is if there was an incident, first responders would respond, and they would stream back live high definition video back from the incident to the control centers, so those working in the control centers could make appropriate decisions on how to respond to that particular incident. So in that case, you know, having that live video feed was extremely valuable to keep everybody in the know on what was going on when there was an incident.
Interesting. Very cool. And folks, just Jason, before we get into this automotive manufacturing example, you know, we're going to limit some of the questions only because we'll try to get to all of them. But there's a lot of questions, George, specifically coming in about like how many 1572s did you use for that particular mine example. So George, I'm going to put it out there, and Jason also will put their contact info so you guys can reach out to them after the fact if you have some additional questions that we didn't quite get to that you guys want answered. So, so Jason, automotive manufacturing.
Yeah, automotive manufacturing presents its own set of challenges. You've got a host of different clients out there in use. So you've got your forklift mounted computers. You've got some of your manufacturing equipment, the actual some of the welders, spot welders and things that will run off of Wi-Fi. Automotive guided vehicles are a big one. They run off of Wi-Fi. That is a very important driver, you know, in these environments, because, you know, if you happen to lose connectivity to one of these devices, you know, there could be incidents where, you know, it could put people in harm. You've got also many different requirements within these facilities. As you can imagine, the layout is quite different from section to section, depending upon the task being performed. You know, in certain plants, automotive plants that I've been in, you know, they do stamping, where they actually stamp out the fenders and the trunk lids and the spoilers and everything that you have and whatnot under the sun. When you get into the manufacturing lines, as you can see in the photo here on the right, you just look at the amount of obstruction and the different parts and pieces that go into this. Every part and piece is generally scanned by an automotive technician whose job it is for whatever part of that vehicle that they're manufacturing. So the wireless requirements generally in these areas are fairly stringent, and they are often difficult to, again, this is where we run into, you know, how do we get power, how do we get data into these areas when not necessarily the switching infrastructure had existed. So, you know, we have to think about the wired infrastructure quite a bit in these areas, because they were never intended to be set up for wireless deployments.
Interesting. Okay. Very cool. And by the way, folks, his experience with automotive manufacturing, don't get into a car and drive with him either. Like he's automotive, no. That's
I'm an excellent driver, just like that man.
Well, we're just giving you grief. All right. So I'm really curious about this one. So pipelines at the North Pole. So
yes. So actually the one on the left was a pipeline up in Fort McMurray, and so I've been to that pipeline a half a dozen times at least, and that was one of the nicer times. I can tell you that in February up in Fort Mac, it can regularly reach -30 to -40. For those of you who do Celsius and Fahrenheit, -40 is -40 in either or. So let that sink in for a minute.
No.
That's right.
It can be a very challenging environment from the aspect of the remoteness of it. We would carry everything there, so I would often ship pallets of survey gear, tools, LMR cable, you name it, anything that we thought that we might need, because it wasn't like we could just go down the road to a Home Depot or a Lowe's and pick up that gear. The other thing is wildlife concerns. So, you know, in the case of Fort McMurray, you know, brown bears, grizzly bears, you know, foxes, wolves, all of that was present there. So, you know, anytime that there was a spotting, you know, we would get a call over the radio, and if it was anything serious, it was take cover until we got the all clear. Now, for the picture on the right, that was for a place called Svalbard, which is in a very northern island. It's actually the farthest north settlement in the world, at 78 degrees north. And as you can see from that picture there, that was the first photo that I took in the parking lot getting off the plane. And if you know anything of Disney World, a polar bear would shred a grizzly bear in a second. So there's that much danger involved. Everyone that worked in the town or would be working out on the plateau where I was definitely carried a firearm. We actually had a couple of gentlemen that their only job in life during the shifts out there were to be on polar bear watch. They generally carried a very large caliber rifle, something 300, I'm going to say like a 300 Weatherby mag or above. And if there was a polar bear alert, they would have you either shelter in place. In that place could be a radome and a very large antenna, or a building, an enclave, you know, anything until the all clear sign was given, because polar bears basically do what they want when they want to. And if they smell the slightest bit of food, they will come, they will find you. So
that's pretty crazy. Like when you think about challenges and environments, polar bears is not the first Wi-Fi challenge that comes to my mind when you're working on a deployment, right?
Correct. It's you know, you're usually thinking about, you know, channel utilization and spectral reuse and things like that. You don't really think about things that might eat you in these environments.
So question real quick on that, Jason. Metal gets very brittle at a certain temperature. So how did you guys combat some of that when it was -40? I mean, did you run into any of those type of issues with your equipment?
It does actually. So it's quite often that the antennas will have to be replaced on a annual or biannual basis. Due to, so you can see some of the areas there on the pipelines, some of those areas vibrate quite a bit. So, you know, proper not only weather sealing from water ingress, moisture ingress, but also vibration. You know, you want to use a self-amalgamating tape generally when you're deploying antennas in these areas, not only to keep moisture out, but to keep them from vibrating loose. Some of the other challenges, I will say in Fort McMurray specifically, be aware of the ravens. They're very smart. They will get into your car, open your backpack, take your sandwich out, and be gone before 30 seconds before you can even get to them. They are extremely intelligent birds.
That movie, The Birds, is coming to my mind.
Yes.
That's not okay, Jason. It's not okay. All right. So Jason's dealing with polar bears and ravens, and George is dealing with remote control bulldozers. So let's talk about underground, right? So we're above ground looking at some of those things. Jason, why don't you share with us some information about this underground storage facility?
Yes, AKA the Batcave. So this is a facility that was in Missouri that formerly was a limestone quarry. I think it's about 24 million square feet in total. And it was cut out basically to mine limestone. So there are driving paths through this facility. And literally when you go into the main glass doors, they open up like the Batcave and you enter. This was very good for cold storage because of the insulation factor. So the biggest challenge in this environment was, you know, everybody's heard that AP per room. Well, in these cases, in these areas where we have racks, you know, there were multiple APs in the room, but there was no chance of any signal escaping any of these areas. The second biggest challenge was cable paths. As you can imagine, these places, when they were mined, weren't designed with cabling involved in the future. So a lot of core drilling went into effect in order to make cable paths, data paths for all of the PoE cables that were required for the AP runs, along with electrical.
Interesting. Okay. What would you say is your biggest challenge in this one?
Biggest challenge in this one is staying warm. You know, a lot of times these areas are much like Fort McMurray. They're a -20. You will feel it in your body after walking around one of these all day. The second challenge is knowing where you're at and having an open line of communication to your team. You can very easily get lost in one of these caverns, as I did for the better part of a half a day, until somebody came and found me. So always keep an open line of communication of where your last location was with your team, because again, this place was gigantic. There was no way that you could find one.
What kind of network were you putting in this facility?
In this particular this particular facility, we were using, if anybody remembers, the Cisco 1300s. They were a ruggedized AP that used coax to do their backhaul, their wired backhaul. So we were deploying those in this area only for the simple fact that they didn't require an enclosure and they were able to operate in these temperatures.
Interesting. So we're going to pause on that one real quick. George, someone had a question, the backhaul. So I'm just going to read it for you. So for the backhaul, 5 gigahertz on the mesh, are you using 5 gigahertz or 2.4 to broadcast out?
Yeah, so we have to preserve the 5 gigahertz for the backhaul. So it's just for backhaul. The 2.4, obviously, it goes a little bit further. So we had 2.4 for client connect, 5 gigahertz for backhaul.
Okay. Very
and
cool.
that is the same in our case with the wireless instrumentation. You know, while the wireless instrumentation was 802.154, we preserved the 5 gigahertz for the backhaul, the 2.4 gigahertz for client connectivity on the ground.
Okay.
Now, I will caveat that, you know, certain manufacturers will allow you to do a backhaul and client connectivity on 5 gigahertz. The only problem that you run into is that the radio is only going to do one transmission at a time. So if it's, communicating to a client, you're not going to have much of a backhaul. So always try to preserve the backhaul for backhaul.
Okay. So quick question, and I'm going to have each of you answer it. George, how did you go about starting to do site surveys for this stuff? Like what was your process, equipment, like what did you, how did you go about it? And then Jason will ask you the same.
Yeah, so on the mining side, it's very unique because, you could do a survey today, tomorrow it's not going to look the same because they're going to do blasting it, in the afternoon and start, digging it up the next morning. So a lot of times it's orientated to wherever the mining is at. So for example, in this particular case, we're just trying to get sensory data. So what we would do is they would sometimes have 3 or 4 operations going at any given time. And effectively, we would make a hotspot of an area for each given location. So each trailer, there'd be 1 trailer per location that we would blanket. And, we played around with a number of antennas for some time and then came up with the antenna solution that we use, which are the sector antennas, to really give us a nice blanket coverage in a given area. So it's not your traditional site survey where you're going to go out and start mapping an area. We would map 1 or 2, kind of get an idea of what the coverage is going to look like. And then we know what that is as we start to move this trailer around, what potentially it's going to look. Now, as for the automation, again, now that does require a site survey because you want to make sure that you're meeting the specifications, the SLA for, of course, voice and video being the more demanding application on the automation of the dozers. So there is a site survey that goes into play with that. And sometimes it's very challenging. Some of these areas you may not be able to get easy access to, that you have to do, get PPE on, you have to get certain types of authorizations, especially if it's an area, if it's an autonomous area, you just can't drive into these areas. So sometimes the operation needs to move or shut down. But once you do a survey in that area and in that particular area where we're doing the remote control dozers, those are actually on stationary buildings. So we know that's not going to move because they're just pushing product down chutes over a large area. So typical site survey, Ekahau, many times we're going to use the sidekick. We're going to calibrate it to the radio that we're using. Really appreciate that calibration tool in Ekahau because that allows us to very easily move from working in a hospital with a sidekick and calibrating to an iPhone to working in a mine and calibrating to, let's say, an IW 3702, for example. It does take some testing to do your comparisons, but I know fairly certain that, once the testing is done, we know what our calibration numbers need to be, so we can see exactly what the RF looks like from the standpoint of that dozer, for example.
Yeah, and that's a really important part. And for some of the folks out there that want to know what George is talking about is the device offset section within our tool.
Mm-hmm. So Jason, let's talk about some of the site surveys that you did in your environments. You know, how did you approach it? What was your process in that as well? Same question.
So it really was a evolutionary process of site surveys, especially within the refineries. You know, of course, we had the requirement for the actual site surveys, which that required a lot of what's the word I'm searching for, trial and error until we got down a good process. So just imagine this. Imagine, you know, you've got, and at this time it was 1552s because they were class 1 div 2 rated radios with ISA 100 radios built within them. Imagine having to climb up a set of tanks, 60-foot tanks, and deploy 4 of these in a mesh deployment, okay, with homemade batteries that we created in-house. And once you went up and you deployed all of these, then you would have to go back up and turn on your batteries because you only had so much time for battery life. Then imagine come lunchtime, you've got to go back and climb up these tanks, turn the batteries back on. One of the biggest processes that I implemented was I actually added a 385 megahertz remote to my battery packs. All in all, because I'm lazy. I don't want to climb tanks. If anybody's ever climbed tanks, it is a strenuous process and it will strip the weight off of you. So basically what I was able to do was climb the tank one time, and then via the remotes, once everything was ready, we would turn the battery packs on. We would test the mesh links. We would test client and instrumentation connectivity to the ground back to the database to make sure that we were seeing good RSSI and SNR. And then we would move on. It was very much a lather, rinse, and repeat type thing.
Very cool. So we're going to talk about some tips. I mean, obviously you gentlemen have been doing this for a while. You've had a lot of exposure to these different types of environments. So what would you say, George, we'll start with you, top 2 tips for these type of environments? Like what would you, lessons learned or tips that you would suggest folks start with if they face themselves with this type of deployment or this type of?
Yeah, you know, for the mining and automation, two very different animals, right? Both of them obviously understanding expectations. What are they trying to achieve? What kind of data is going to be transferred over the network? All too often, I find folks just say, well, I need a wireless network. Okay, that's great, but what are you going to use it for? You know, we might do some data here, data there, and you know, iPhones and tablets, but then what about voice and video? No, I'm not doing it today. Are you planning on doing it next year? Yeah, next year. Well, you want to design for that, right? So understanding expectations. That is so critical, because without expectations, you don't know what you're designing. Yeah. Very poor wireless networks, very poorly designed wireless networks work. You could see that. Jason's networks work. So, I mean, it speaks volumes. So, sorry, Jason. But no,
touché, George, touché.
And, you know, it's after you have those expectations, and then make sure you're designing to those expectations. And many times you need to exceed those expectations. And as a wireless engineer, very much like Jason has shared in his slides there, it's more than just zeros and ones. There's so many more challenges. You get one shot to run that cable because it's going to cost $4,000 or $5,000 to run that cable in conduit and get it to the spot where you need it. And you just can't go back and say, yeah, we want to move it over there. So it's understanding those expectations, designing a network that's going to exceed expectations in many cases. But those are 2 really large lessons learned. And the last one I'll just share is that, you know, once the network's up and running, you really have to do your due diligence. You have to break it so you know what broken looks like. How far are you able to stretch that network till it starts to fail? You know, some of our longest links were over a mile long. So we needed to make sure we had the right antennas for it, right? And that also has to, you know, for example, we have to train miners to actually align these trailers because they don't call us every time they need to move a trailer. So literally you have to make this so easy and design it in a very robust manner that, you know, you got a miner who's going to hop off a dozer and move that trailer and then align it back up and using lights. Okay, I have a green light. You know, it's good. So a lot of lessons learned from that perspective.
Interesting. Jason, what about you?
So I will touch on the shortcuts, and this really goes into the safety aspect. So I was actually at a refinery where two guys lost their lives one day, and it was for no other reason than people didn't plan out correctly, and there were shortcuts taken. This was highly avoidable. Unlike in your enterprise wireless, when you walk into one of these environments, there are things that can seriously hurt or if not kill you. So that's my first tip is not to take shortcuts. The other thing is to expect the unexpected. All of the planning in the world, all of you can ship all the right equipment, you can plan for 8 months, you can do everything along those lines, and then you get on site and the town of Fort McMurray catches on fire. And if anybody remembers that a couple years ago, that was, I think, one of Canada's most major disasters. I happened to be there and had to evacuate during that time out of there. So
I did not know that. I did not know that you were there at that time.
I was in Fort Mac at that time, yes.
Wow, that was a major thing.
Mm-hmm. Yeah. Okay. And what else, Jason? Give us one more besides safety, because we're going to talk about safety concerns here in just a minute.
Sure. So, most of these environments that I've worked in, although they're not like enterprise environments, I call them nature's greenfield. Mm-hmm. It's usually a very clean spectrum in these environments. Albeit, these are pipelines, North Pole, whatnot. When you walk into a refinery, there are all sorts of non-protocol compliant devices that are running. So I've often used the Sidekick spectrum analysis tool to go in and pinpoint a lot of those devices. And it actually now is an annual requirement in some of those refineries to go ahead and to do a spectrum analysis to look for some of these non-protocol compliant devices, see what their use cases are, and see if they're really needed or not.
Interesting. Okay. So you guys mentioned PPE and some of that stuff. So Jason, why don't you explain what that is, understanding safety, some of the concerns in those type of environments?
Sure. So, your PPE is your personal protective equipment. That's everything from your OSHA certified glasses, hard hats, reflective vesting. Not all reflective vesting is created equal. There are different classes. Safety wear on your footwear. Footwear is very important depending upon the environment you're working in. You might be working in Canada in the muskeg, and you might need something that's completely waterproof. You might be working in a refinery where you have to have a half-inch instep on your heel. In the cases of refineries, gas detection is also very important. H2S, amongst other, CO2, O2, and other flammable gases. So you always have to have a gas detector on you. My most least favorite is, so working in refineries in the summertime, you also have to wear head to toe Nomex. That is a fire retardant overall suit, basically, that you could be working in 110 degrees in 50%, 80% humidity. Not the most comfortable thing to do, but should there be an event, it will save your life to a degree.
Interesting. And George, what safety in some of those environments? I mean, I know except for when you're in the pod, but what about when you're doing the site surveys, you're looking at in the mine? What safety tips, do you have for folks as they're working in those environments?
Yeah, some customers require that there's mining certifications that one has to go through a mining safety course, typically 3 days. And then once a year, they have to do a 8-hour refresh. So some of your larger mines require that. So it's an added expense. Not only taking the class, but that you have to pay for as well. The safety class 1 Dev 2, you're in high gas areas. You have to be aware of that. PPE, Jason kind of covered on that. High vid vests, glasses, steel toe boots, all those things.
Ear protection.
Hearing protection. That's right. So it's very similar. When you go into mining and you go into chemical, they pretty much have very similar requirements. A lot of the companies even have site specifics where you have to take, sometimes an hour video or more and do a quick test. But one of the things that I think is so very important, and Jason kind of hit on it earlier, is that in these areas, you really take it for granted and until an accident happens. And one day we were actually on another project some years ago, and a gentleman, he fortunately didn't lose his life, but he did lose some fingers. He wasn't part of our group, but he was part of the project, and he just wasn't paying attention. And he was using a saw and took off his fingers. But dangers are all around you. You can never be comfortable. You always have to be at high alert, because these trucks, they don't see you. They just don't see you. Especially if you're walking around.
Right?
What's that?
You have to make eye contact, even in underground.
Oh, absolutely.
It's like, you've got to stop. You got to be really aware and alert. And
you have your larger companies. They have very strict policies that you don't get out of the truck, for example, and walk around. Your smaller mines, they're kind of mom and pop in a lot of ways, and they allow that. Some mines allow us to drive our personal vehicles down in the pits. Others don't. There's a lot of caution that you have to really and be prepared for anything.
Yeah, and to touch on what George had said there, I'd left something out too. So, we go through a certification called Basic Plus every year that touches on all of the safety aspects that you're going to run into a refinery. And then, of course, there is a refresher course. If anybody who's in a refinery right now can see that I haven't been to a refinery for quite some time. One of the requirements to work in a refinery is that facial hair is a no-no. You have to be able to don a respirator. Even if you haven't had a fit test and there's an event, the chances are that putting a respirator on you and somebody dragging you out of an event will save your life. So if you have a beard and you want to get into the refinery game, you're going to have to get a razor.
That's crazy. And so one quick question, George, someone had asked, do you ever worry about sabotage with the equipment, leaving it out there with the autonomous vehicles and some of that stuff? Like, have you ever had to deal with something like that?
So physical security versus, technical security. A lot of these mines are remote. So they're not, they're not on the beaten path. The mine has personnel there 24/7. A lot of these mines are 24/7 operations. There are times when the mine may go down for maintenance, where they may overhaul some of the trucks. A lot of times, like let's say, for example, if the bottom falls out of coal, they'll shut the mine down for a few weeks. And then when the price picks back up, then they'll start mining again. Many times when that happens, they'll pull in the equipment and they'll put it in their laydown yard where they have cameras. But as far as sabotage and the physical security of the devices themselves, they're typically always going to be in an area that's being mined. So it's not very far off. And again, pretty remote areas, unless somebody's actually going out there to target it, I don't see it happening.
It's funny you mentioned that, Tawny, because I actually have had a few incidents where we've had sabotage, specifically in some refineries, to access points where people have done nothing more than taken the antennas, grabbed them, and broken them off, and purely intentionally because it was caught on camera. And what it did was ended up being a disgruntled employee.
Interesting. Well, hopefully, you guys don't have to deal with those things for everyone in our audience in your strange environments that you're dealing with. But I did find really interesting as we wrap up here today, George, you were talking about going from a hospital to the mine. So you're using the same Ekahau tools in each environment and able to do so, correct?
Oh, absolutely. Yeah. The Sidekick is a game changer for us. No longer do I have to carry a bunch of Orinoco Proxim nicks. The ability to now do file capture on the Sidekick, as well as spectrum analysis. I mean, there's less tools I have to bring. Just bring the Sidekick, and I'm pretty much solid with data collection, spectrum analysis, and doing RF coverage reading. So regardless of the mine or the area that I'm in. Only thing is I get a little concerned because, you know, the site, it's a very dirty and dusty area. So we've improvised some by, you know, putting a cover over top of the sidekick. So we, you know, prevent the dust and dirt from getting in there. But absolutely, it's a multi-purpose tool for us.
And Jason, I know same for you. You guys use a sidekick and you're using your EcoHow tools in all of your environments.
Very much so, and especially in the power plants where we can get into some of the boiler environments that can often exceed 120, almost to 130 degrees Fahrenheit. We've actually had quite a bit of success in running the sidekick in those environments, and without losing any data or with the device actually overheating.
Yeah, wow, that's pretty crazy.
It is.
I think about, you know, just how intense those environments can be, right? So
Stay hydrated, my friends.
yeah, exactly. And not with whiskey, right? Absolutely with water. That's what you're talking about, right?
Yes, please.
So to wrap up, you know, make sure in these type of environments you have the right tools that you need. Make sure you're aware of your surroundings, understand expectations, and prepare. And what I wanted to do, because I know we didn't get to all the questions, but I wanted to make sure everyone had a way to get in touch with George and Jason if they had additional questions and follow-up that they wanted to ask. I know there was some questions regarding some location tracking, George, for some of your stuff. And so I know folks had those questions there. So I wanted to leave this here for everybody. But with that being said, once again, George, Jason, this was a wealth of knowledge. Thank you so much for taking the time to talk to us, because, you know, I think that a lot of folks, we don't get to hear about those type of environments. We hear about higher ed, we hear about LPV, we hear about enterprise deployments, but we really don't get to understand it and hear a lot of real live examples about those hazardous and those stranger, different environments that you're operating in. So
thank you for having me specifically. I appreciate the opportunity to definitely talk about these environments, and I welcome any questions that anybody has. Reach out to me on Twitter, or I don't think my email address is on here, but you can find me at jbashara@gmail.com if you have any questions.
Awesome. Thanks, Jason.
Thank you guys a lot. This is it's been some really cool you know, chatter in the chat room and the Q&A, and so it's you guys highlighted some really cool points. So this was really good. I've also had some experience as well, much as George has had in underground mining and dealing with stuff. But you know, only my takeaway is that when it comes to understanding the safety aspect of it, take your time and think ahead of time before you get on site whether or not you need the special certifications to get there, and because that'll save you a lot of pain, right? Sometimes you may not be allowed to be on site without a drug test. You know, you have to get a special
Background checks.
Background checks. Yes, better believe it, it's there.
Since I didn't have any hair, I used to have to get my leg shaved every 6 months for a drug test. So imagine what that looked like.
Wow.
Yes. They will take it from places of your body where you have hair.
Only you, Jason. Only you.
Well, Jason, you're well prepared now with that beard.
No, they're not touching the beard. You can go after the legs still.
All right, folks. With that, we'll end it. Thank you, everybody in our audience who joined today. Once again, if you have any questions, please feel free to reach out to George and Jason or over to the EcoHow team over here. You know, we'd be more than happy to answer any questions that you have. But specifically to George and Jason, if you have questions that we didn't get to about the environments that they're working in. So everybody have a wonderful day, the rest of their day, wherever you are. George, go to bed. I know George is, of course, in India right now. It's very, very late. So thanks again. And everybody have a wonderful day.
Thank you, everybody. Take care.
Thanks again.